Okay, inverse variation. This is obviously different than direct variation. Section 9.1, as x gets bigger, the y values get smaller. And the equation for simple inverse variation is y equals k. There's a constant of variation, k. But this time it's being divided by x. Other examples are k over x squared or k over x cubed, something like that. Obviously, k cannot be 0, otherwise we would be talking about a horizontal line again, and we're not going to be dealing with something like that, an inverse variation. And that you'll notice the graph, specifically only in quadrant 1, as the x values get bigger, the y values get smaller, you're going to get a curved shape like this. And we'll talk about this picture and what it means, and different things. That there's even values for the negatives, but most of the time when we deal with story problems, we're only dealing with positives. But we'll deal with both when we get to a more broader picture of that equation. Example 1 says, suppose x and y vary inversely, and x equals 3 when y equals 5. Write the function. All right, so if I know that there is an inverse relationship, it says x and y vary inversely. That means y equals k over x. And x equals 3 when y equals 5. It says write the equation, or write the function. In other words, they gave me enough information for me to find out that the k value is 15, right? I'm going to multiply both sides by 3. All right? And when I do that, then I have enough information to write my final equation, y equals 15 over x. Well, then they're going to go on to say, okay, now that we know that, why don't you find y when x equals 7? So if we know that the k value is 15 and the x value is 7, then we can plug those in and get 2 1/7. Obviously there's a decimal equivalent to that, 2.14, I'm sure. So, but you can figure that one out on a calculator. All right, we're going to have questions like example 2, which are pretty much like multiple choice. Your 3 choices will be direct variation, inverse variation, or neither. Now, we talked about how direct variation was determined by taking the y values and dividing by the x values. And if you can do that, and every time you come up with the same number, then that's direct variation. Well, if you look at y equals k over x and do just a little bit of modification by multiplying by x on both sides, what you end up with is this: xy equals k. In other words, the product of the two numbers is the same number every time. Now, I know that gets confusing because we talk about direct variation being multiplication, and we talked about inverse variation being division. And so that idea gets very messy for a lot of kids. So you're going to have to work very hard to make sure you understand the difference between them. So for instance, if I'm trying to figure out this, chart right here, y over x, that'll be direct relationship. X times y will be inverse. And if I don't get the same number in this column or the same number in this column, then I have to conclude neither. So let's see here. If I take 1.5 and divide by 0.5, I get 3. If I take 6 and divide by 2, I get 3. Okay, this is looking pretty good for her. I'm not quite positive yet, but 18 over 6 also gives me 3. So I can make the conclusion that this is inverse variation or direct variation. So this is y equals 3x, which is obviously directly related. Okay, so I'm going to extend my chart and do the same type of thing here. 12 divided by 0.2 is 60. 4 divided by 0.6 is 6.6 repeating. Okay, those two numbers are obviously not the same. So I can automatically stop. I don't even have to do the third value because I know it's not direct relationship. So I'm going to go to the next column. 12 times 0.2, 2.4. 0.6 times 4, 2.4. Okay, this is looking promising. Never just go on two numbers. You must go through the entire table. 2.4. Okay, so I'm concluding that this is inverse variation this time. And the equation that we're dealing with is y equals 2.4 over x. All right, let's try it again. Obviously, 2 over 1 is 2. 1 over 2 is 0.5, so I can stop with that column because those two numbers aren't the same. 2 times 1 is 2. 1 times 2 is 2. 3 times 0.5 is not equal to 2. I don't care that it rounds to 2. These are not equal. So this one is a neither situation. It's not direct, it's not inverse, it's neither. By the way, I'll write that down in here, inverse, just so everybody remembers. Inverse goes with the division. Okay, we're going to run into story problem situations. Now, I'm not going to go through the entire example 3 in the book because it's no different than really looking at example 1. But we have situations where we deal with the heart rate. It'll say something like the heart rate varies inversely as lifespan. So here's the relationship between heart rate and lifespan. Please make notice that K, the constant of variation, was not mentioned in the language that we used. So you have to remember that K is there. For instance, then we're going to start getting into combined variation. Y varies directly with the square of x. So here is a different direct variation. We talked about this one in section 2.3. But this one is y equals kx squared. Notice nothing was mentioned of k, but you have to remember it. What about this? Y varies inversely with the cube of x. Y varies inversely, that's k divided by the cube of x, x to the third. So you have to be able to take this language and convert it into an equation to use. Now, there's a term called joint variation. When you see the term joint variation, that means that all the variables to follow will be directly related, or direct variation. So when you see something like this, z varies jointly with x and y. That means z equals k times x times y. It is all the variables to follow are directly related. But because there's more than one, we don't want to say directly with x and directly with y. We say varies jointly. That means that's telling us exactly what's going on there. Now, I know that many of you celebrate a couple different, you might celebrate one of the more notable Algebra 2 national holidays, Pi Day. That's coming up on March 14th in a few weeks from now. Okay, so I'm sure everybody will celebrate, Pi Day. But the second national holiday that's coming up this spring has everything to do with joint variation. It is National Joint Variation Day, and we celebrate that on April 20th. So, mark that on your calendars, National Joint Variation Day. We'll have a lot of fun with that. Continuing on with more combined variation, we have Z varies jointly with X and Y and inversely with W. Okay, now we're throwing more stuff at you. Z varies jointly. Okay, that's directly related, right? Don't forget K. With X and Y. And then it says, and inversely with W. So that's going to mean that I need to divide by W. Also, so we might have direct and inverse relationships all in the same problem. This is what we're calling combined variation. We're putting everything together. Here's another one. Z varies directly with X. Okay, let's get that part down. Z varies directly with X. And inversely with the product. Okay, what's product mean? That means multiplication. The product of W and the cube of Y. So it's inversely with two things. The product of, now I don't really need those parentheses. Those are fairly useless, but I just want to make the point that it's one product of W and the cube of Y. So if you decided on a quiz or test to write Z equals KX over WY to the third, there's absolutely nothing wrong with that. I just want you to realize that the W and the Y to the third are being multiplied together, but they're in the denominator of the fraction, according to the language here. The product of, so it's inversely with the product. Not just inversely with one, but inversely with the product. Example 4. Example 4 is a situation where we're talking about the force and, of the magnitude. You got gravity and a couple different planets and their relationship and the pull on each other. So use words to describe this formula. F varies jointly with G, M1, and M2, and inversely with the square of D. Okay? Now, I didn't have to mention, anywhere in there I didn't mention the K value. What's the K value in this situation? Looks like a big 1 for me. K is equal to 1. But we did not mention the K value anywhere in the language of what we wrote. You're going to be faced with other situations, other formulas, and you're going to have to do the same thing, such as V varies jointly with B and H. Please make note that there is no mention of the K value. Do you know what the K value is in this case? Most students do not know it correctly. The K value is 1/3. I know the people say, oh, well, you're dividing by 3. Isn't that inverse variation? No. Another way to write this is V equals 1/3 times B times H. So there's your K value sitting right out there in front. Division is the same as multiplying by the reciprocal. Here's another situation where you'd have to write out the language of variation. Okay? V varies jointly with the square of R and H. Now you say to yourself, how come you didn't mention pi? Well, what is pi? Pi is your constant of variation. It's a number. It's not a variable, so don't treat it that way. You don't need to mention pi in here because it's not a variable. This description is only the description of the relationship between the variables. That's it. We'll talk more in class.